Hi students, welcome to my teacher. Today we are discussing finite and infinite sets. So this is the last topic of 10th class mathematics sets chapter from Telangana state. To understand what are finite and what are infinite sets, let us consider a few sets here. The first one, A is equal to set of the students of your school. Now, the first one is set of students of your school. Children, how many elements will be there in this set? Means how many students are there in your school? Those many elements. So, can we find the number of elements? Can we express the number of elements of set A in whole number? Means how much, what is the strength of your school? That is the number of elements. So we can express the number of elements in a whole number. So it will be a finite set. Now that means we understood that a finite set is a set where it will be possible to express the number of elements in a whole number. Means finite number of elements are present in that set. Now let's see here. L is a set where it contains P, Q, R, S elements. Can you tell how many elements are there in this set? Yes, we can. How many are there? 1, 2, 3, 4. Yes, so 4 elements are there. That means we can express the number of elements of this set in a whole number 4. So it is a finite set. Now let's see here. B is equal to set of x such that x is an even number. Children, what are even numbers? 2, 4, 6, 8, 10, 12, so on. Can you tell how many elements are there in this set? 4, 5, 10, 100, 1000? No, we cannot tell exactly. Means we cannot express the number of elements of this set in a whole number. So it is not a finite set. When it is not a finite set, then it becomes infinite set. Means the number of elements of this set cannot be expressed in whole numbers. So it is an infinite set. Now here x is a multiple of 7. What are multiples of 7? Let me list out. 7 2s are 14, 3s are 21, 4s are 28, come on, so on. So how many elements are there in this set? Here also we cannot express the number of elements in a whole number. So that's why it is also an infinite set. So children, what we observed here is if we can able to express the number of elements of a particular set in a whole number, then it is a finite set. If it is not a finite set, then it will be an infinite set. Because there are infinitely many even numbers, this is not a finite set, means infinite set it is. And there are infinitely many multiples of 7, hence this is an infinite set. So children, we understood that if a set contains finite number of elements, means the number of elements of a particular set can be expressed in whole numbers, then the set is a finite set. And if it is not a finite set, it is an infinite set. Means a set contains infinitely many elements in it. So now let us state whether the given sets are finite or infinite based on the number of elements present in them. Right. So first one is like this. Set of x such that x belongs to n and x minus 1 into x minus 2 is equal to 0. Here the condition is that x is a natural number and x minus 1 into x minus 2 is equal to 0. So from this, x minus 1 is equal to 0 or x minus 2 is equal to 0. Why? Because when the product of two things is equal to 0, one of them must become 0. So that implies x is equal to minus 1 outside 1, or x is equal to, when minus 2 is transposed to other side, plus 2. So then the set contains elements 1 and 2. So how many elements are there in this set? Yes, there are 2 elements present in this set. So number of elements is equal to 2. Since we can able to express the number of elements in a whole number, it is a finite set. Therefore, it is finite set. Now let's see the second one. It is like this. Set of x such that x belongs to n and x square is equal to 4. X is a natural number. The condition is x square is equal to 4. If x square is equal to 4, x becomes root 4. Yes or no? Right. Then that is equal to plus or minus 2. Here x belongs to n. Means x is a natural number. Natural number means it must be a positive one only, not a negative, because negative numbers are not there in natural numbers. So x is equal to 2 only. And then this set is set of 2. Now how many elements are there in this one? Just one element. So number of elements is equal to 1. Therefore it is finite set. Let's see third one. Set of x such that x belongs to n. X is a natural number and 2x minus 2 is equal to 0. 2x minus 2 is equal to 0. That means 2x is equal to minus 2 transposed 2, and x is equal to 2 by 2 into 2 other side by 2. 2 ones are. So x is equal to 1. Then this set contains only one element. Number of elements is equal to 1. Since we can able to express the number of elements of this set in whole numbers, it is a finite set. Therefore, it is finite set. Let's see the fourth one. Set of x such that x belongs to n, means x is a natural number and x is prime. So prime natural numbers. See, what are prime natural numbers, children? 2, 3, 5, 7, 11, so on. So can you able to find how many elements are there in this? No. So there are no finite number of elements present, means the primes are infinitely many. Therefore, it is not a finite set, it is a infinite set. Since there are infinitely many primes, it is infinite set. Yes, so it is an infinite set. So last one. Set of x such that x belongs to n and x is odd. So x is a natural number and odd numbers, means odd natural numbers. What are our odd natural numbers? 1, 3, 5, 7, 9, 11, so on. Here also the same. Since there are infinitely many odd numbers, it is an infinite set. So let me write the same thing. Since there are infinitely many odd numbers, it is infinite set. So Like this, we can find whether the set is finite or infinite based on the number of elements present in it. So children, we have seen finite and infinite sets. Now, if we say the number of elements present in a set in a whole number, and that whole number is the cardinality of the finite set or cardinal number. How many elements are there in a particular set? That number is called cardinal number. See here how we define cardinality of a finite set. The number of elements in a finite set is called the cardinal number of the set or the cardinality of the set. So pretty simple. So number of elements of a set is called cardinal number. Now, cardinal number of a set A is denoted as n of A. So like this we have to denote the cardinality of a finite set. N of A, N of B, N of C. N of B means the cardinal number of set B. N of C means the cardinal number of set C. Means how many elements are present in set C, like that. So let's see few examples here. Suppose A is equal to set of 1, 2, 4. Now the cardinal number of set A is n of A is equal to how many elements are present in set A? 1, 2, 3. So the cardinal number of set A will be 3. That's it. As simple as it is. Now let's see next example. B is equal to set of 6, 7, 8, 9, 10. So what is the cardinality or cardinal number of set B? N of B is equal to, children, count the number of elements and tell me. Yes, they are 1, 2, 3, 4, 5. 5 elements are present in that. So the cardinal number will be 5. Let's see the last one. C is equal to set of X such that X is a letter, means an alphabet, in the word India. So in the word India, what letters are there? They are there in the set C. So C becomes set of I, N, D. I is already written. It should not be repeated. We know this already because the elements of a set are distinct. So I is already there. A. So what is the cardinality or cardinal number? Cardinal number of set C means n of C, number of C, 1, 2, 3, 4. So it is 4. Like this, we can write the cardinality of a finite set. Children, now let us solve exercise 2.4 from this chapter. See here, the first question is like this. State which of the following sets are empty and which are not. So we have to state whether the set is empty or not empty. Empty means a set with no elements. Not empty means there should be at least one element in it. Let's see here. The set of lines passing through a given point. So through a given point, set of lines. Children, how many lines can be passing through a given point? Yes, infinitely many. You can draw many lines passing through a given set of points. So, is it an empty set? No, obviously not, because there are many lines that can be possible to draw a pass through a given point. So, what we will write? There are many lines passing through given point. So it is not empty set. So it is not an empty set. Let's see the second one. Set of odd natural number divisible by 2. Children, what is the definition of odd number? Yes, odd numbers are the numbers which are not divisible by 2, or the numbers which leave remainder 1 when it is divided by 2. So here the statement gives no element in the set because odd numbers are not divisible by 2, right? Since odd numbers are not divisible by 2, it is empty set. Means it contains no such element. So it is an empty set. And the third one is set of x such that x is a natural number. So x is a natural number means it is from 1 to infinity. It could be any number. And the condition is x is less than 5. What are less than 5? 1, 2, 3, 4, right? And x is greater than 7. Greater than 7 could be 8, 9, 10, so on. So is there any number which satisfies both the conditions because x is less than 5 and x is greater than 7? So tell me one number which is smaller than 5 and greater than 7. No such number is possible. If it is smaller than 5, it is not greater than 7. If it is greater than 7, it cannot be smaller than 5. So there exists no element in the set. Therefore, it is empty set. Now let's see this one. X is such that x is a common point to any two parallel lines. Any two parallel lines. Say P and Q are parallel lines. Children, can you tell one common point for these two parallel lines? No, because the very definition of parallel lines is that they do not have a point in common. So there cannot be any point in common. It is not possible to have an element in it. Therefore, it must be an empty set. It is empty set. Next, last one. Set of even prime numbers. Children, can you tell even prime number? Yes, it is 2. So even prime number is 2. That means this set is having one element. So is it an empty set? No, it is not an empty set. So if a set contains no elements in it, it is an empty set. So in this question, it is asked to find whether the sets are finite or infinite. So once again, let us discuss about finite and infinite. What are finite sets? A set in which the number of elements can be expressed in a whole number is finite, and if it is not, then it is infinite. Let's see the first one. Set of months in a year. Children, what are the months in a year? Yes, they are from January, February, so on up to December. So there are 12 months in a year. So it is a finite set. Good. Now let's see this one. Set of 1, 2, 3, so on 99, 100. So up to 100, these are natural numbers. So obviously the number of elements in this set is 100. So we can able to find out number of elements in it. So it is a finite set. Let's see here, third one. The set of prime numbers smaller than 99. So prime numbers are from 2, 3, 5, 7, 11, so on, which is smaller than 99. So smaller than 99, maybe up to 97. So this is also a finite set because there are finite number of elements present in it. So even this is a finite set. Yes. Set of letters in English alphabet. Yes, there are finite number of alphabets. There are not infinite number of alphabets present in English language. So what are they? Set of A, B, C, so on up to X, Y, Z. So there are 26 alphabet. So we can able to find the number of elements in it. So it becomes a finite set. See the fifth one. Set of lines that can be drawn parallel to x-axis. So parallel to x-axis, how many lines you can able to draw? Any number of lines we can able to draw. Infinitely many lines can be drawn parallel to x-axis. So it is an infinite set. Set of numbers which are multiples of 5. Children, what are the numbers which are multiples of 5? Yes, 5, 10, 15, 20, 25, 30, 35, so on. So there are infinite number of multiples present in this set. So it is infinite set. Yeah. Now the last one, set of circles passing through the origin 0, 0. So through a point, how many circles can pass through? Through one point, there can be any number of circles passing through. So set of circle passing through the origin is infinite because infinite number of circles can be passing through the given point at the origin. So it becomes infinite set. So this is the way to write or to find whether this is a finite set or infinite set.